All right, in this video I want to wrap up the measures of central tendency and corresponding Excel practice. We left off in part 2 of this bullet here. So it says, using the investments practice data set, find the weighted mean 52-week high for the portfolio, then calculate the arithmetic mean and compare. So to do this, we want to pull up our data here. Looks like we've got each one of these rows represents a particular stock in our portfolio. It tells us the 52-week high for that stock, the price to earnings ratio for that stock, and the market value in terms of our portfolio. So for this stock, we have $1,536 invested. And then for this stock, we have $8,435, so on and so forth. The first thing we need to do is find the total value of our portfolio. We do this by just summing everything we've got invested. So we have $54,281 invested. The next step is to find the weights. Now for the weights, we're finding as a fraction of our total portfolio. So we simply create a formula here, equals each stock and how much we have invested in it, divided by the total. Okay? And because I'm going to drag this down, I'm going to want to lock the denominator. And it's rounded to the 10th, that's fine. We're going to pull this down, and we get each of our stocks, right? Each row is a stock and the commensurate investment. So you can see, for example, we have 2.8% of our portfolio in this stock here, and we have 15% of our portfolio in this stock here, and then so on and so forth. Okay? Now, I like to sum these up because when we're dealing with a weighted average, it needs to sum to 100. The portfolio needs to sum to 100, and it does. The next step is to find our respective weights times whatever we're looking at. So it says here, using the investments practice data set, find the weighted mean 52-week high. So we're looking at the 52-week high. So we're going to take W, which is our weight, and we're going to multiply that times our 52-week high. Okay? And to do that, we simply put an equal sign and multiply our weight times our 52-week high. And then we drag this down. Okay. Now the final step to find the weighted mean is to sum up all of these. So down here we can put sum and bam. Okay, so that is our 52-week weighted mean. We can also, of course, round that. So we have a 52-week weighted mean high of 42. Okay? The next step is to compare that to the arithmetic mean. And for the arithmetic mean, we simply sum all of our 52-week highs and divide that by our number. And it looks like we have, it goes from 1 to 21, but the first row is a title, so it's 20, so it's divided by 20. And you get 41. Okay? So 41 is the arithmetic mean, but 42 is the weighted mean. Which one's more accurate? Well, remember, the 41 assumes that all of our stock is equally weighted because you're dividing by 20, which is essentially the same as applying a 5% weight to every stock. That's not the case, though, in your portfolio. Your portfolio does not have 5% for each stock. It has some stock that is much higher weight, 15%, and some stock that's much lower, 2.2% for this one. So a weighted mean is more appropriate. Another way of thinking about it is, if you want to know what's actually happening in your portfolio, you would use the weighted mean. Okay, now let's look at the last one. It says, using the mutual fund practice data set, find the geometric mean return on the fund. If you invested $10,000 at the beginning of year 1, how much would you have at the end of year 10? Use both the annual growth factor and the geometric mean to calculate. Okay, let's pull the data up, and it looks like here we have 10 years of data and the different returns stated as percentages. Okay, but you'll notice these are whole numbers. We need these stated as decimals. Okay, so 22.1% is actually 0.221. So what we're going to do is we're going to divide each of these by 100. Okay, so we're going to take 22.1 divided by 100. This will convert them into decimals. Okay. Now, once we've converted them to decimals, we then need to add 1 to them. Equals this value plus 1. You'll recall that I am simply referencing this formula here. Okay? The geometric mean is 1 plus the percentage growth rate in decimal terms. Okay? So let's go back and continue. Now we've taken the decimal percent, we've added 1 to it. Now we actually need to multiply all of these numbers. So I'm going to put equals this times 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 this. And I get 1.33. Okay. Now, if I go back to my formula, I've just completed the multiplication part, right? But now I need to take the result, that 1.33, to the 1 over the number of intervals. And the number of intervals that I have is 10, right? Because I've got 10 periods here that I'm seeing changes in returns. So I'm going to take this number equals this number, and I'm going to take it to the exponent of 1 over 10, which is 0.10. And I get this, 1.029. Okay? But if I go back to the formula, I need to take that and subtract 1 from it. So let me do that. Equals this minus 1. So I've got 2.93. Therefore, my geometric growth rate is 2.93. Now, there is another way to get this, and it's using an Excel function. So if we put in here equals geometric mean, geomean, it's going to give us this number simply by scrolling over our data. Now notice the data I'm scrolling over. Excel is recognizing in this function the number 1 plus your decimal percentages, okay? It's not recognizing the decimal percentages or the whole percentages. It's recognizing 1 plus the decimal percentages. In essence, Excel is looking at this portion of our formula, this whole thing right here, okay? So when we click Enter, it's going to give us the same value that we got using the manual operations. Okay? So if you want to get there faster, you can do this, but you still need to do the subtraction of 1. You take this, and then you subtract 1, and you get there. Okay? Put it in percentage form, of course. And you get the same thing. Okay? So less steps for Excel, but the intuition is probably a little bit more laid out here. Now the last question for this one is, what if you had $10,000 at the beginning of year 1? How much would you have at the end of year 10? Well, remember, we've established that the growth rate per year on average is 2.93. So all we need to do is take 10,000 and imagine that it grows at 2.93% per year. There's multiple ways of doing this, but let's do the most illustrative way. Let's take 10,000, actually put equals 10,000, and I'm going to multiply that by 1.029, because this is going to take 10,000, and the 10,000 times 1 is going to be 10,000, but then it's going to effectively tack on the 2.9%. If I do that, I get to 10,292. So that's after year 1. Right? Now I can do it again. I can take this number and multiply it by 1.029. And now, so there's year 2, right, at the end of year 2. And then I do the same thing. Multiply it by this. And that's how much I have at the end of year 3. Let's keep going. This. And that's what I have at the end of year 4. That's what I have at the end of year 5. Year 6. Year 7. Year 8. Year 9. And at the end of year 10. Now, I want you to notice something. This is what we will have at the end of 10 years. And that's pretty obvious when you go through each year, right? If you're investing, you might want to do that so you get a sense of what each year is going to look like. But we could have went from 10,000 all the way to here by using this multiplier here. Do you see the relationship? We could have just taken 10,000, watch this, 10,000, and multiplied it by this, and we get the same thing. This number here is part of what we use to eventually get to the 2.93% geometric average growth rate. So we're just backing up a little bit. And mathematically, what we're backing up to is just this part of the formula right here. Okay? So this part of the formula is a multiplier. It's taking that, it can be used to take an initial value, 10,000 in our example, and turning it into a final value, which is 13,344. Okay? But if we don't want to do that, if all we really want is the average annual growth rate, then we would continue on and take that multiplier to the exponent of 1 over n and then subtract 1. And that's what we did here. We got that multiplier, but then we took it to 1 over 10 and then subtracted 1. That gave us the average annual growth rate, the geometric growth rate. But if we want to actually figure out how we turn a starting value into a final value, we would use this number here and just multiply that starting value by the multiplier here. 10,000 times 1.334493 is equal to $13,344.93. Okay, very useful tools for finance, whether it's personal or professional. These are used every day in analysis. All right, that's it. Let me know if you have any questions. Thanks.